Welcome, and your session today is all about operations research or quantitative techniques or simply quantitative analysis. And to be more specific, we are going to talk about linear programming as used in operations research. And under linear programming, we are going to talk about how to formulate a linear programming problem that involves a minimization case or problem. So we normally have a minimization case as well as a maximization case. If you talk about linear programming, we are referring to these particular mathematical calculations which are used to solve complex problems. These are actually problems that involves a lot of mathematical or numerical calculations. So I want us to go through the equation, after which I'm going to give you the components that make up the linear programming, as well as how to derive those components from this particular information that you have been given. So the question states, an expectant mother has been recommended 3 types of food. We have food A, B, and C that she's supposed to take, packed in weights of 50 grams. So the weights are 50 grams. The cost per packet are 100, 150, and 70 respectively. So it means the cost for food type A is 100, type B is 150, and type C costs 70 shillings. Each type of food has vitamins available with minimum requirement as below. So we have the types of food A, B, and C. Vitamins available in food A, B, and C are vitamin 1 and 2. For example, in food A, the vitamin available is 20 grams, and in food the vitamin B in the same type of food is 10 grams. But for vitamin 1, the minimum daily required vitamin for vitamin 1 is supposed to be 80. In other words, this particular expectant mother is not supposed to go below 80 grams in any single day. Same to vitamin B, vitamin 2, sorry. She's not supposed to go below 120 grams. And of course, the cost per packet are 100, 150, and 70, as we have stated before. But now, this is what the question requires. Determine a linear programming model to determine the optimal combination of food types within cost such that the minimum requirements of vitamins of each type is satisfied. So it's with cost. There's no word within. We're supposed to determine, in other words, we are supposed to determine the minimum requirement of vitamin A and B at the minimum cost possible by using these 3 types of cost. So I just want us to look at what is known as the components of a linear programming model. As in what makes up this particular model that we're going to talk about. The first one is normally what is known as decision variables. Now, decision variables are basically the physical variables which are being controlled in the model so as to be able to either minimize the problem or maximize the problem. In this case, we are going to control the foods A, B, and C. as well as vitamin. These are the physical variables to be controlled in this particular problem. 2, second component is supposed to be what is known as the objective function. So I talk about objective function, we are talking about the main goal. What is the main goal? That is the goal for formulating the model, which can either be a minimization problem or maximization problem. And for our case, we are going to talk about the minimization problem. And then the third component is supposed to be the constraint. So you see, as much as we try to achieve our goals, we have some certain limiting factors or limiting variables, and the variables, they assume any different size, that must be controlled. In other words, constraints are simply those factors or variables which tries to prone a challenge in achieving the main goal of whether minimization or maximization. Like in this case, we have our constraints given in this the table. For each and every type of vitamin 1 and 2, we have the constraints for every type of food given as these figures here. So we begin by identifying the decision variables as we formulate the problem which we have. Second is determine the objective function. So our objective function essentially is supposed to be minimizing the costs of vitamin, and you can talk about C. So if you talk about minimize C, for example, we minimize the cost of vitamin C, and the cost components are given in the table as 100 for vitamin 1, for type A, 150 for type B, and 70 for type C. And if you let the cost of each type of food to be X1 for A, X2 for B, and X3 for C, we are supposed to know that the minimum cost of each vitamin should be 100 times X1, which is X1, plus 150 X2 plus 70 X3. This is the objective function. So our objective function has been formulated. And these particular objective functions, they are subject to certain constraints, which are the variables which are trying to restrict the achievement of this particular goal of minimization of the cost. And the first constraint is supposed to be 20x for x1 plus 30 for x2 plus 10 for x3. And we are told that the minimum daily requirement for vitamin 1 should not be less than 80. So it means that all these compound variable is either greater than or equal to 80 grams. We go for the second pair of constraints, which should be 10 x1 plus 30 x2 plus 20 x3 should not be less than 120, means it should be either greater than or equal to 1 20 grams. But now there's another obvious type of a constraint which is referred to as the non-zero constraint. So the non-zero constraint here, we are referring to the value of x1, the value of x2 and x3 should be greater than or equal to 0. We don't have any non-positive or negative constraints. So this is actually how we formulate an LLP model for a minimization case, after which now you'll be able to solve it further. Thank you very much, and kindly subscribe to our channel for more videos.